Today my presentation will be about determining artificial neural network treatment algorithm to predict the content of water in the moss. Now we are using the RGB intensities to guess it. So first, my presentation will be divided into 5 main parts. So I will make a brief introduction, and then I will describe a little of the experiment. Then I will explain some of the techniques used. On the fourth part, I will explain the results, and then I will make a conclusion about all these papers. So first, you can see that on the agriculture, we need to automatize the irrigation system. So for this purpose, there are some precision irrigation systems using machine vision in the plant factory. So in this paper, they choose to import the precision irrigation system of the Sunagoke moss. The real name is Rachomitrium japonicum. It's a moss found in Japan. And here you can see on the photo the Sunagoke moss. So it's mainly used for biowalls and biogreening to reduce the heat of the urban heat island. So the urban heat island is when the city becomes warmer than other rural cities because of the human activity. So why did they decide to take the Sunagoke moss? It's because the moss have a high level of dehydration tolerance, and we can see that the water stress is the main limiting factor, because the water stress decides of the speed, the quality, and the color of the moss. So if we got optimum water, we got optimum photosynthesis, so we got optimum speed, quality, and color. So it's an ideal land for studying water stress detection techniques, because we can see if we can see clearly if this really works, if the water stress detection technique really works or not. So here, a little description of the experiment. So they decided to take 10 samples of Sunagoke. So here is the camera, and there are 2 lamps. The power light of the 2 lamps are 22 watts, and the light intensity is about 100 micromole meter per square per second. So here a little explanation of how the experiment will pass. So first, with the camera we take an image, and then we calculate the RGB graph. We can see the normalized pixel of RGB, and then we put this graph into an input of the feature selection. What is the feature selection? It's a method to remove irrelevant and redundant features. So after removing all those redundant features, we put that in an input of an artificial neural network, and then we can guess the water content of the moss. So what is exactly the feature selection? It's a bio-inspired method algorithm. So they decided to try 5 bio-inspired methods. So the first one is honeybees mating optimization. So they simulate the mating of the queen of the bees to guess what features can be removed and what features are redundant. There is also the ant colony optimization. It's about the ant finding some food and finding the best way, the best path to bring the food to the main colony. There is also the genetic algorithm. So this one is simple. It's about natural selection, about genes. There is also the simulated annealing and the discrete particle swarm optimization. So all these algorithms are a method to optimize the data before giving to input in the artificial neural network. So in this network, they decided to use the backpropagation neural network, which is just an artificial neural network with 3 layers, the input in the layer, and so here are the results of the RGB histogram of the moss. We can see that on the 1 and the 2, these two are soaked condition and wet condition. We can see that they are almost the same color histogram. We can see that when they are, the more they are dry, less intensity we have, and less number of normalized picture we have. So here are the performance of the different FS models. So we can see that it's a graph about average error, the root mean square error. Here's the formula. So it's for calculating the amount of errors, and we can see that the HPMO is the Univ mating optimization. We got the lowest rate of error. And here is the performance of the artificial network mixed with some of the feature selection. So we can see that here is also the root mean square error. You can see that if we use the backpropagation neural network mixed with the Univ's mating optimization, we got the lowest rate of error too. So in conclusion, in the paper they could see the performance of the backpropagation neural network as the artificial neural network. So they could see if they could see that it really works, and also they have proven that we can improve the precision through the feature selection techniques. So after seeing the results, we can see that the backpropagation network used with the neural speed mating optimization was the most efficient, predict the water content. And in the final conclusion of the paper, you can say that this type of micro-precision irrigation system can be applied for the Sunago. Thank you for your attention. Do you have any questions?
It's time for questions and comments. Please.
Thank you for your presentation. Can you put the slide about the RGB results? Yes, this one. Can you explain more about the difference from each slide and each picture? Thank you.
Okay. Here is the results of different conditions of moss. So we can see in the RGB histogram that if the moss is soaked and on the wet condition, it's almost the same color histogram.
So between the most soaked one and the most dried one, And seems like only the red intensity has the difference because
No, there is also
the division of the blue and the green seems not different so much between the sock and the dry one. Only the red can see the difference.
maybe it's because you're far, but there is a real difference between the blue in the soft condition and the dry condition. But it's just that here we can see, because we can't see a lot of red, so if we decrease the red, we notice more. But we can see here that there is a real difference near like 45 blue intensities. Any more questions?
Do you know if this could be applied for any other moss or just this specific type?
This could be applied for other moths if we do the same operations, like taking specific histogram colors, and maybe try other feature selection system and see what is the best for optimization.
Thank you.
So, question and comments from Japan?
Are there any questions here? It's your chance to practice. No? I have a question concerning the moss and the heat island effect. Is it being utilized in the cities of Taiwan very much now?
Can you repeat the question? Because I didn't hear very well.
Okay. The heat island effect and the use of greening on the rooftops of buildings in the city, is that being done very often in Taiwan?
Is it used often in Taiwan?
Yes.
I don't really know because I'm not Taiwanese. And a lot of roofs, so.
Oh, okay. Okay. Thank you very much.
Maybe I can make some comment.
Okay.
Instead of moss on the top of the roof, usually grow vegetables on the top of the roof. So in addition to do the purpose of the moss, absorb the heat, also we have something to eat.
Okay. Very good.
Just one suggestion. That your first page should show the your name. Please, we need some score. So that's why we need your name. Your first page. Okay. Next time.
That's all from this side. We now go to the next presenter, please.